In this video, we're going to talk about inflection points, and we will be interested in finding the inflection points of this famous function e to minus x squared. Okay, we will see, and I think we have seen some of it when dealing with some computation of probability. Okay, anyways, so here to find the inflection points, we need to compute the second derivative and study its sign. Okay, so first, the second derivative of our function is 4x squared minus 2 e to minus x squared. Okay, now we want to find the points where this second derivative is 0. So we to do that, we solve. Okay, so here f second is 0 means that 4x squared minus 2 e to minus x squared is 0. But we know that e to minus x squared is never 0 for all x's in R. Okay, therefore we have to solve 4x squared minus 2 is 0. And this means that 2x squared minus 1 is 0. And we can factor this one as square root of 2x minus 1 times the square root of 2x plus 1 is 0. Therefore, we have x is either plus or minus square root of 2 over 2. Okay? So these are the points or the values of x that would make the second derivative 0. Okay? Now we need to see the change of sign of the second derivative at these points. Okay? To say that these are inflection points. Okay? To do that, we're gonna make a small table. Okay? That's the easiest way, I think, because we don't want to do the line and keep guessing. Here we're gonna do this. Okay? So my x takes value between minus infinity and plus infinity, because the domain of my function is the whole set of real numbers. So here, square root of 2x minus 1, square root of 2x plus 1, and I'm interested in the sign of the second derivative. Okay, so I know that my function, which is f second, is 0 when it's minus square root of 2, and it's also 0 when it's plus square root of 2 over 2. Okay, to do that, here, put a 0 here, put a 0 here. Okay, so if x is less than minus square root of 2 over 2, my function is negative. If x is minus square root of 2 over 2, it's, I think here, it's 0. And if x is bigger than the square root of 2 over 2, it's positive. Here, a similar study shows that this minus here, plus, plus. Okay, therefore, I have a plus, minus, plus. Okay, I see now my second derivative. So it's positive. It's increasing here. Its sign is positive. And that means it's concave up. And it's 0 here and concave down. Okay, so it's 0 at this point, and it changes sign. Okay, that means it changes concavity, the function. Also here, it's negative or concave down, and at 0, it changes concavity to become concave up. Okay, so here I can see it here from here. Okay, this means that when I graph my function, and this is the aim of this video here. So before we used to graph it like this and just go. Okay, we don't do an emphasis on these points. Here, to do that, we will make sure that we get these points. I will try my best. Okay, I'm not sure I'm gonna get this one. Okay, so I'm just doing this to make sure that we get the inflection point here. Minus square root of 2 over 2 is minus 0.7, I think. And this is 0.7. Okay. Okay. So let me go and do it here. So here, Okay, so no matter what you do, because the key is that it's concave up, and here you see if you keep going, it's I'm trying to make it look like, but you see the idea here. It's concave up if you keep drawing here, and it's concave down and concave up here. You feel it. Okay, you can feel that these points here, we don't see them, but the aim of the video is to show you that this one has 2 inflection points. Okay, these points are very important. Okay, so the aim is to show you these 2 points. Okay, if you see a third one, let me know. Maybe there is a third one. No, there is only 2. Just joking. 2 points given by this one. I'm talking only about the x values, 0.7 minus 0.7, and statistically speaking, we're gonna see why these 2 points here are very, very important. Okay, so the key idea is finding inflection points means finding the points that would make the second derivative 0 and also changing sign at these points. That's the good key to check for inflection points. Okay, if you see any errors or mistakes, please let me know. Thank you very much. Enjoy the video.